Welcome to my basement. These are my two 3D printers. They're both Creality Ender5 machines. The one on the left with the red is an Ender5 Plus, and the one on the right with the green is an Ender5 Pro. I'm doing some maintenance and work on the Ender5 Pro on the right, so today just wanted to show in this video how I start up and get a 3D print going for the Ender5 Plus on the left. In between every few 3D prints, it's good to do a 70% isopropanol wash on the build plate surface. So this is a polypropylene build surface, so you want to pour on a bit of alcohol here. And then use paper towels to wipe the alcohol across the whole build plate surface using a circular motion. We all remember wax on, wax off from the Karate Kid, and that works here. Don't need to apply a lot of pressure, just get the alcohol nice and spread out evenly across the build plate surface out to the corners. You can see the shiny, glossy look with the wet alcohol, so you know where you got the surface cleaned. I had a clump of paper towels here, so flipping over to the dry side, giving it another wipe over to help clear out the excess alcohol and let it start drying so that it'll be nice and clean for a fresh 3D print today. While we're letting the build surface dry, my Ender5 Plus is not a stock machine. I've made modifications to it, so just want to talk through briefly what those changes are and what's on this machine. So if you're watching this video, you know what I'm printing with here. So I'm not going to take parts off or anything, just going to point in on specific areas and talk through what's different and installed on this machine, starting with the hot end here behind the, it is the stock Creality fan shroud there, of course, but the hot end underneath is a Slice Engineering copperhead heat break and heat block with the 300C thermistor and heater cartridge from Slice Engineering, and that's been working well. I do have the Vanadium nozzle also from Slice Engineering. It's a 0.6 millimeter, and the heat block sock, silicone sock from Slice Engineering. I like to print with carbon fiber and glow in the dark, which are abrasive materials, and the setup's been working well to print those items. The extruder on my Ender5 Plus is from 3D Maker Engineering. It's a dual gear drive of their design with 3D printed parts and a lifetime guarantee. The build plate surface, as I mentioned during the isopropanol wash, is polypropylene. It's from 3D Maker Engineering. I do have the original glass that came with the machine from Creality. I like that surface. The black carbonundrum that's on the glass from Creality works very well, with PLA at least. I wanted to try PETG eventually, and some other materials is part of why I switched to try this polypropylene from 3D Maker Engineering. Under the build plate is a heated bed, and at the bottom of the heated bed are adjustment wheels. I have red aluminum that I changed out the stock ones to level the four corners, and then also silicone bumpers in place of the springs that came stock on the machine. So the red aluminum wheels are just an aesthetic. I like the color and the look of those, but then the bumpers really help keep the consistency of the bed level week to week over time with printing. More consistent than the stock springs that were on the machine. Looking under the heated bed towards the back, you can see this red elbow-shaped 3D printed part, which is strain relief for the wires coming off the heated bed, so those didn't get caught up or tangled. And then 3D printed cable management clip there on the back. The Ender5 Plus comes with a filament runout sensor, which I've actually taken off my machine with the prior extruder. I had some filament get tangled and actually wore out the mechanism inside the filament runout sensor. So didn't replace it, ended up just taking it off the machine and manage my printing and volume of filament without needing it, and I don't really miss it. So I have a few other 3D printed parts on the machine. The first is for the front bar. brackets that lower that bar so you can see the build surface better, particularly for the leveling process, but also just a better view of the 3D printing. Also have the tool holder for Allen wrenches and a few tools that I routinely use. Sitting on that is, of course, my dragon mascot for this machine. On the other side, I have a Wyze pan cam that is nice to remotely watch printing on the 5 Plus or turn and watch on the 5 Pro. And it's on a base that I remixed the design from online. You can also see another red bracket underneath. It's for an Gulf Coast Robotics LED light bar that holds the power button on the clip there. When I have that installed, it's not currently on the machine, obviously. For the print today, just using some basic PLA. It's Inland brand from my local Micro Center. We'll go ahead now and talk about some of the components that are on the inside of the main control unit of the Ender5 Plus. I did get lucky with this one and had a Meanwell power supply. A lot of Ender5 Plus users are familiar, and Creality users are familiar with the Landry kind of generic power supply. My Ender5 Pro did come with that Landry unit, and I did swap that out to a Meanwell. Inside the Ender5 Plus here, I do have the Big Tree Tech SKR 1.4 Turbo control board, and the display on the front there is also Big Tree Tech TFT 35 version 2 inside the 3D printed display housing. I have an SD card adapter. This was meant for the Ender 3, and I was able to just mount it with some screws through the vent openings here on the inside to hold the SD card holder. It's a little easier to put an SD card in and out of the machine than a micro SD. So that's been working well. And with the SKR 1.4 Turbo board, having access then for the SD card here to load prints, but have the USB cable to be able to do printer calibrations and interface with that system. I did have to open up a little bit on the case here with an extended USB cable, so there's a little bit of a cutout there to make that hole bigger. For the two Z-axis motors here on this Ender5 Plus, I do have the 2209 drivers on that 1.4 turbo board so that they can be independently controlled. We'll use that for Z-axis alignment during the bed leveling process. All right, the build surface is cleaned and fully dry now, so we can get started for printing today. We'll go ahead and kick on the power button, and the BLTouch lights up red. And then we'll watch for the Marlin firmware loading screen to tell us the machine is ready to go. And now it is. So where the hot end is located here at the back corner of the machine is where it parks after the last print. So the first thing we're going to do is go in to motion. We'll do an auto home first. So it's going to check the X and Y end stops, which this is an end stop, and you can see the yellow back there. And then for the Z-axis end stop, the BLTouch with the probe extended in that by that little blue light. And the build plate is rising up so the machine can hold its positions. Now that the machine is honed, after the machine's been sitting, and actually in between prints I do this too. I mentioned that I have the individual stepper drivers for the Z-axis motors, and as we go through the bed leveling process to get ready for a print, we want to make sure that, because it has the two Z-axis rods, that those are even, because if they are not even just a 0.1 millimeter out of alignment, that can make leveling the overall bed surface a little more challenging. So we'll come into motion, come down to auto Z align, and you'll see it will probe on the left Z-axis side first, take a few measurements there. Then we'll check the right side. You know, the firmware settings, it tells how many times to check each side, and it has to be within a specified tolerance for the two sides. If it's not, then it will go back and remeasure the other side, and it will keep doing that like it just did, going back there to the left. And it will make micro adjustments on the positioning of the individual Z-axis rods on either the left or right side until they're within the tolerance to be level between the two. So it measured the left once and the right once. It found it wasn't within the tolerance. It went back to the left, did measurements. It still wasn't within tolerance, so now it's gone back to the right. Measuring again. And now it's within tolerances, so it goes back to the middle to finish Z homing again. It's common for it to need to do some multiple alignments there between the two Z-axis sides after washing the bed. I wasn't pushing down hard on the bed, but just touching the bed and doing the circular motion with cleaning. Any little bit of movement like that is possible to get the measurements out of adjustment slightly. So that's why it's good to have those Z-axis motors on individual stepper drivers and be able to start out leveling with the machine, taking the measurements like that. All right, now that the machine was homed and the Z-axes were aligned, we're ready to start heating up the build plate. And we're going to be printing just standard PLA today. So we're going to preheat the bed to 60 degrees. You can see there the temperature is measuring about 17, so it's got a little bit to heat up to 60. And for the first print of the day, I like to let it get good and warm and calibrated with the everything heating and warming up. So we'll give it a good 15 minutes at least before we come back. Alright, the build plate's been heated up to 60 degrees for more tan 15 minutes now, so everything should be nice and warmed up and expanded and ready to start the leveling process so we can get a 3D print going. So the first thing we're going to do is come into motion and go to bed leveling, down to level the corners. So it does another home of X and Y first, comes back for the Z homing position, and then it's going to probe the four corners essentially underneath the red aluminum adjustment wheels so we can check how close the level is. So I actually like to use the backlight method to set the Z offset position and do the bed corner leveling. So this is an insert video just showing a 0.1 millimeter gap between the nozzle and the build plate that I raise and lower a couple times to illustrate that. So when I set the Z offset position and then also go around on the four corners, I make sure that the nozzle is just barely touching the build surface. We'll go ahead over to here. And that is right on the money. You don't see any gap in between the nozzle and the build surface. I'm just having it go around for this video. I have checked because it's a little hard holding my phone for the video here to get up close on each of those spots, so I did that ahead of time. There we can see the center position as well. The nozzle's right on the build plate, so we got a perfect level in the center, which is good. And now that we're done with the 4 points, we can come up and let the BLTouch do a 25-point measurement. So the probe extends and it'll do a 5x5 grid across the whole build surface and create a mesh sampling of those distances. So you get the idea as it's moving across the front here. I'm not going to record it all. We'll come back once it's finished and ready for the next step. And now it's at the 25th position of the grid, making the final measurement. Alright, now the BLTouch has finished that 25-point grid. In the menu, when you scroll, you'll notice the bed leveling indicator there just switched from off to on because it completed that 25-point grid process. So we can now come back up to the top of the menu, scroll down to our print files that are on the SD card, and this is the print that I have for today. Temperature, of course, for the hot end, which you can just see it just kicked on to heat up to 215 degrees, which is what I calibrated for this inland black PLA on my machine. And it's starting to heat up. I do notice a slight increase in how fast this Slice Engineering heater cartridge will heat up. So that is one. It's just seconds difference. It's noticeably faster, but it doesn't really change much in terms of timing. I do keep a pair of needle nose pliers right by the machine so that I can grab a little bit of ooze that always comes out the nozzle. So now the nozzle moves over for the prime line, and sometimes it'll have a little bit of filament there catch on the nozzle as it goes down. I just scoot that out of the way so it doesn't catch it on the way back. Just for cleanliness, sometimes it'll drag it over as it starts the skirt line for the print. But my Cura settings, I have it set for 3 skirt lines just to prime the filament and make sure everything's running smoothly. I can also check on the skirt lines just to make sure that the bed leveling process was done well. Shouldn't be any gaps between the lines. This polypropylene build plate with the green, especially with black filament like this, it can be easy to see if there's any gaps between the layer lines or the lines of the walls. So even just here with the first 2 lines of the skirt that have come by, able to tell that there's no gaps and the leveling is spot on for today. And so able to tell it finished the skirt, and now it's starting the actual 3D model for this print today, which has 2 circles in the center there that it starts with. And that back one happens sometimes. The filament gets caught up a little bit during the retraction as it's coming out of the nozzle for the first time, even with the skirt lines priming. So there's a little bit of a smudge there on the back. It doesn't look severe enough. I expect that as it completes the first layer of the model here going around. And then definitely with the second layer, it'll smooth that out on the back circle. It's not a severe enough blob to cause an issue for today. So we'll let this first layer of the model continue. Won't record it all, and we'll speed up time a bit for you as the viewer to be able to check back in and see how the first layer ends up. I like to avoid using my hands to pull any of the filament off the build surface if I could avoid it, so I use tweezers to pull off the prime line. And I'll do the same with the skirt lines at the end of the print as well. So just checking in a few times here as the first layer continues to fill in. And it's always hard with the fan shroud and hot end moving back and forth to get a good view and especially a picture or video of the process. But again, with the contrast of the black filament and the kind of greenish polypropylene color of the build plate, we'd be able to tell if there were any gaps between the lines as it's going along here with this first layer. Everything's leveled and filled in pretty nicely. No first layer issues from what I can see here. So we should have we can expect a good 3D print, at least as far as the first layer has started out. And now it's on to the second layer, and you can see that blob there at the back, it's getting flattened down just as the next layer gets applied, so that won't cause any issues for this model at all. So now that we have the 3D print started for the day, want to mention a few YouTubers. I'll put that in the video description as well, but in particular, Kersey Fabrications is a key one that with this Ender5 Plus, I was able to follow along his videos and do the Big Tree Tech upgrades and compile the Marlin firmware from his versions that he was able to provide. So big shout out to Kersey Fabrications. Tripods Garage, 3D Maker Noob, and a number of others as well helped me in my learning and education on 3D printing. So I'll try to acknowledge all those again in the video description. But yeah, this print is going well and should have a successful outcome in a few hours. So I'm not going to record all of this 3D print today, but just to be able to show, since you've been watching this video, what's printing. I already printed one of these earlier. It's here on the left. It's a base for a football trophy. So I'm commissioner of the Fantasy Football League, and we have a trophy that we give to the winner each year. I didn't win this year. I won last year. But yeah, printing the trophy for this year's winner in the league. The last little video here to include is a view from the Wyze pan cam that I use from the Wyze app to check in on the printer when I'm not right next to it. So this is what that view looks like with that mount on the front bar of the Ender5 Plus.